Good afternoon, ladies and gentlemen. This is the first exercise on river basin planning that is being taken in India. Ganga Basin is one of the largest basins with a catchment area of about 1 million square kilometers. The river runs across 3 countries, Nepal, India, and Bangladesh, the catchment area. In India, it covers almost 11 states. We have 2 upstream rivers, you can say. One is called the Bhagirathi, which originates from ice caves at Gaumukh. The second very important upstream tributary of the Ganga River is Alaknanda. And after the confluence of these 2 upstream rivers, Alaknanda and Bhagirathi, we call this river as River Ganga. The entire length of the River Ganga is about 2,500 plus kilometers. If you look at the issues and the concerns of the River Ganga, we can divide this basin into 3 parts, what we call it as the Upper Ganga Segment. It's about 300 kilometers from up to Rishikesh. This is mostly in hilly terrain. The challenges that we face in this particular part of the river, that the river flows on steep and narrow bed, mostly rocks and boulders. It carries cold water, is subjected to much less anthropogenic pollution, has highly sensitive and fragile ecosystem and diversity. But the most important challenge that we face is there are many hydropower stations which are coming up, hydropower powers which are coming up. So the most important challenge in this is to consider to have potential for harnessing hydropower, but that is going to have a huge impact on the river itself. And as you can see, on these 2 upstream stretches of the river, number of hydropower plants are planned. Some of them are already there. And out of 300 kilometer stretch of the river, hardly 80 kilometer river stretch, you can say, is the river which flows like a river. Otherwise, it is either ponds or lakes converted into that fashion. Similarly, the other upstream stretches, you can see the number of hydropower plants, lot of tunneling and other activities that goes on. So on one side, we have this economic activity going on. On the other side, we have challenge of keeping the ecology status maintained. When it comes to the lower part of the Ganga, that is the middle and the lower segments of the Ganga, it enters into the plains. The challenges there are very different kind. The middle Ganga stretch is about 1,000 kilometers from Rishikesh to Varanasi. It's a very famous place, Varanasi. And the lower Ganga portion, we can say, is about, again, another 1,100 kilometers from Varanasi to Ganga Sagar, where actually river meets the sea. If you look at the issues, it enters and flows in plains, meandering mostly on bed of fine sand, has very wide riverbed and floodplain, and also is thickly populated, this region. The most important part is much of the water is abstracted, and we have very low flow coming in. So most importantly, modified through human interventions in terms of huge quantities of water diversion, abstraction, and subjected to high degree of pollutant loads from domestic, industrial, and agriculture. We have intense domestic, industrial, and agricultural activity in the middle stretch of the river, where the flow is very low, and much of the flow is abstracted upstream for irrigation purposes. In the lower segment, the issues are very different. River has experienced considerable changes in the sediment transport and deposition, causes widespread flooding in Bihar, West Bengal, the lower part of the Ganga Basin, undergoes frequent changes in her channel path. So river is meandering and shifting from one side to the other, and most importantly is subjected to international disputes on flows and interventions made and are being planned or carried out on this river. So recently, the government of India decided to make the holistic Ganga River Basin Management Plan. It is the first time this assignment has been given to a consortium of 7 premier institutes in India, and I happen to coordinate that activity on behalf of the 7 IITs. This was formally done by signing the MOA between the Ministry of Environment and Forest and the Minister of Human Resource Development, who represents the IITs. It's almost about 10 months that we are into this exercise. Our mandate is basically to prepare the Ganga River Basin Environment Management Plan, which will restore the wholesomeness of the river Ganga. Now, it's very difficult to define what is this wholesomeness of the river Ganga, particularly in the light of the belief that the people have. This is very important, particularly with respect to river Ganga. People of India in general and all others believe that the Ganga is something very special, particularly with respect to the water quality of the river. Believe that water quality is exceptional, and we need to protect that exceptional water quality from its origin to the destination. There are some scientific evidences to suggest that yes, Ganga has some special water qualities. Of course, it is not conclusively proved scientifically, but there are beliefs, and people of India would like to make sure that that quality is maintained. So our challenge is basically to make a plan which protects the river system. At the same time, we have growing population, industrialization, urbanization, and agricultural activity, for which we need to make sure that we have enough soil, land area available. It demands a lot of water, and of course you require energy. But what does it mean by protecting the river system? So we have defined 5 formulas for protecting the river system. If you call river, it must continuously flow. That's one of the things. There should be no dry patches. The second aspect that we are looking at is it must be unpolluted. The third formula is the river must have connectivity, longitudinal, vertical, and lateral connectivity. The river requires space for its own functions. Normally we talk about space for our own functions, but we forget about the space that the river requires. So adequate space for various river functions. And of course, the river should be looked at as an ecological entity. Our philosophy is we cannot afford to experiment with rivers like Ganga. So wherever the knowledge gaps exist, we would like to use precautionary principle. We do want to use modern science, new technologies, but the traditional knowledge is equally important. So though the IITs are mostly scientific technical institutions, we do want to go to the people, want to find out what their feelings are about the river and what do they know about river traditionally, and that's what we would like to incorporate, the scientific knowledge plus the public knowledge while preparing it. We do talk about supportive capacity and the assimilative capacity of the rivers. By and large, our strategy is to leave the assimilative capacity of the rivers to something which we do not know, which we do not understand. But for known sources of pollution, we do not want to utilize this assimilative capacity.